Okay, this is the third video segment that I'm making about subtle issues in mechanism design, and it's really intended for the people who just start the subject to be familiar with some of the pitfalls that one can be facing with. Now, this is the same problem that we did in video 2. Let me remind you what it was. We have a track here which is 20 inches long. So 10 inches to the left, 10 inches to the right, and we have a block, and on top of that there sits the propeller. And what we like to do is, there's a marker here, by the way. There's a marker here, this magenta marker, which represents the global x equal to 0. Okay? Now, at the moment, there are no rules here, there are no formulas, there are no laws, there are no rules, and therefore this basically is, there's no physics into the problem. Let me first double click on this revolute joint, and let's make this thing angle driven, 0 to 360, okay, and double click on the prismatic joint and make it length driven. Now at the moment the range of motion minus 100 inches to 100 inches, but really I want this thing to be 0 and 10 inches long. So the other thing is, I've noticed that there is a blue arrow here which shows you positive motion is in this direction. I don't want it. I want it to go to the left. Click on the arrow to turn it to the other side. And why don't I make this thing minus 10 to 10 inches. Actually, it really doesn't matter. I just wanted it to go from here all the way to the left, which means 0 to 10, but I just left it as minus 10 to 10. Now, notice that we got the message that the simulation this time can be simulated. Okay, so if you ever get the dimmed color here, means that you have selected the tree. Either you put the cursor on these white branches and left click, or put the cursor on the XYZ coordinate system here and left click. Now, first of all, the degree of freedom is 0. When I made it angle driven and length driven, then consecutively the degree of freedom was dropped by 1, so it went from 2 to 0. This is why I have two sliding bars here. This one gives you the 360-degree motion of the propeller, and this one gives you the 10-inch motion of the block. So let me reset it and leave it there. Now, I want to put some physics into the problem. Initially, I actually, if I'm not mistaken, in the previous video, I put some formulas, and I'm going to do the same thing. But later on, I would like to come and give it this kind of emotion. So in this video segment, I will do the block motion following this path, meaning the position of the block versus time is given like that, and therefore velocities are also calculated quite easily. For example, 10 inches over 5 second period is going to give you 2 inches per second, etc. And later on, well, I don't know whether it's going to be in this video or in a follow-up one, the motion is going to be like this. Although these look the same, but there's one major difference. If you compare these two, you notice that the break point for when the propeller and the block motion are specified are the same. So 5 and 8, 5 and 8. So something happened at 5 inch and 5 second and 8 second to both propeller and the block. On the other hand, this other motion, which I may be able to do it here or in a follow-up video, the break points are different. When it comes to this approach, eventually I can do this thing with a single rule, or I can do it with two rules, one for the block, one for the prop. But when it comes to here, to do it with a single rule, it gives you a rather long C program. So instead, it's better if we do this thing as two rules. one rule for the block and one rule for the prop. Initially, of course, we're going to assume that this has a constant uniform velocity, and therefore we can do it with a formula. You go to the f of x, you click on the mechanism, only the stuff related to the mechanism pop up. So for example, the first one is the angle. Notice that when I selected this line, the command for angle is lighting up here, and I say add a formula. Let's say this turns 36 degrees in 1 second. No, actually, yeah, let's assume that it goes 36 degrees in 1 second. That is not consistent with this, but this is not the problem that I'm doing right now. What I'm doing is a uniform velocity for the propeller and the block times time. Where's the time? Times down here. Okay, and then I do one for the block. So add a formula. Let's say it's 1 inch per second. 1 inch divided by 1 second times time. Okay, and let's do it over a 10 second interval. So simulation with laws, and 10 seconds, and we play it. Of course, it'll go all the way to the end. The block travels 10 inches, and the propeller goes 1 full revolution. Rewind. Okay. These are the formulas that I typed. But when it comes to specifying this motion, you cannot just specify it with a single formula. So that formula that I created, that kind of a feature is not going to work. So what we need to do, we discussed this thing before in the lab and in the class. These are not in the book though. We need to go to the. No, I have to write some code. So we go to start. What is that? Knowledgeware and knowledge advisor. And there is, it says reactive features, whatever. And this, if you look at the icon, it says if X, I suppose, then Y. You click on it, and you get a rule editor popping up. Now, this first problem, I'm going to initially do it with a single rule. Okay. I'm going to leave it to, well, I'm going to do it with, how about doing it in separate rules? Okay, well, one rule, first we're going to do both of them in the same rule. So we say, okay, and notice that, well, first of all, if you click on the mechanism, only the stuff related to the mechanism show up right there, okay? So, let's see. Right. These formulas that I wrote like this for you, okay, I'm going to put it instead of formulas of that like that in a rule. So we say, obviously there are no if statements here. It's a uniform, velocity. So angle equal to 36 degrees in 1 second times time, and then position equal to, or the command for prismatic joint equal to 1 inch over 1 second times time. So these are exactly what I typed here, except that these were inputted as formulas. This is as a rule. When I say OK, it tells me that, look, these commands were already specified in the tree using formula. If you say yes, it will deactivate these formulas and use your C program instead. Are you sure? And the answer is yes. And notice that these two got deactivated, and instead I have a rule. I mean, if you double click on the rule, it'll take you to that window right there, and you can make changes if you need. I don't want to make any changes. And say OK. Now let's do a simulation with laws, 10-second interval, and exactly the same effect as before is going to pop up. In other words, the block travels 10 inches and the propeller turns once. Rewind and OK. Now, if I wanted to, I could have done two rules, one for the prismatic joint and the other one for the revolute joint. But here we could put them both in the same rule. Okay, now, if we go to this problem, now the rule is not going to be as simple. It requires some if statements. If time is less than 5, this is what the formula is. If time is big but less than 8, this is what the formula is, etc. So obviously it becomes more involved. So by the way, I'm going to leave these here, but if I wanted to, I can delete them. Okay, but I'll leave it. So double click. So I have to make some changes here. Now, let me erase all of these. Erase all of these for now, because if you look at these velocities, the velocity of the prop and the block is different depending on when you are. So that's why I deleted it. The other thing is that on purpose, I'm going to make mistakes, or at least on purpose, I will write it the way it makes sense, but then we get warning messages or error messages, we're going to have to come and fix it. Okay? So, if time is less than 5 seconds, okay, then the angle equal to, just look at this graph, the angle is equal to 180 degrees in 5 seconds. So I'm just going to literally write it, 180 DEG divided by 5 seconds. Of course, I could have written, what is that, 36 degrees in 1 second, same thing, times time, okay? And then the length is equal to, can you look at this? The length is, the velocity is it goes 10 inches in 5 seconds. So that's exactly like it is, 10 inches in 5 seconds. I could have written 5 inches in, what is that, 2 inches in 1 second. Okay, same thing, times time. Okay, there will be a mistake here, you will see. Else, if time is less than 8 seconds, just look at the graph, see, less than 8 seconds right there. Okay, 8 seconds. Angle equal to, if you look at that graph, it's 180 degrees. And length is equal to 10 inches. And finally, else, another, if you're past 8 seconds, angle equal to, now do not forget to write 180 degree plus, because on top of the 180 degrees that it was there, it starts growing. Plus, if you look at your velocity profile, you see that it goes 180 degrees in 2 seconds or 90 degrees in 1 second. So that is exactly like it is. You just look at the graph, 180 degrees in 2 seconds, 180 degrees in 2 seconds, times, parentheses, time, and do not forget to subtract 8 seconds from this. Okay, then length equal to, But do not forget to write 10 inches plus. 10 inches plus. Very, very frequently we forget to write these initial values. Plus, look at the graph. It is going to be 10 inches in 2 seconds or 5 inches in 1 second. Okay, so 10 inches in 2 seconds times time minus 8 seconds. Don't forget, 8 seconds must match. Okay, good. Now, when I say okay, everything looks okay, everything looks good, except that I will get a syntax error. It says invalid structure, syntax error near this. The reason this is happening is that if you have 2 lines to be executed, if something, then this, and then that, you need to put them in the braces. This is why it's complaining. So I'll put a brace here, and I end it there. That's what was complaining. And then again here, and then again there. And finally here, and there. I think this time it's going to work. You should be prepared to go back and forth between these rules that you write, because there will be syntax error. Sometimes you forget to write, for example, S, your IN, or degree, and these are all syntax error. It worked. Okay, so let me close that, and then simulation with laws, 10 seconds. Believe me, the same thing with, believe me, well, wait a minute. What do you mean, believe me? What we should get is reproducing these graphs. Now, first, let's actually run it and see what happens. Then we have put some sensors here so that we can plot graph. Okay, 10-second interval, right? So this goes for a while and then stops. Everything stops and waits for 5 seconds and then moves on. That's exactly what we expect. Okay, just look at these graphs. Goes somewhere, stops there at that location, everything stops. The block stops, the propeller stops, and then after 8 seconds, it begins to roll. Now, how do we plot things? Or how do we create those graphs? The first thing that we need to do is, I'm going to close this. We're going to create sensor. Sensor, ball rolling down a ramp. The reference product is that track. And the point is, it really doesn't matter. You can take this point, you can take that point. It really doesn't matter. Actually, what I want to show you is that when I try to do the simulation with laws and activate sensor, one way of graphing that is the angular position of this and the x position of that. The other one is x vertex. Okay. The other one is to select the first 2 items. These are mechanism and these are commands. Okay, these are the commands. So instead of going here and selecting the x vertex and then other things, all we have to do is to activate these 2 and play it 10 seconds. It stops there for a while and then moves, right? Yeah, good. When it reaches the end, then we're going to say graph it. This is exactly what we have in these 2 graphs. Okay? Excellent. Now, let me close this, close that, rewind, and say okay. Okay. Now keep in mind that I could have done separated this into 2 rules, rule 1 and rule 2. Except that rule 1 would be, for example, only for the angle, and in rule 2, the other program, only the length, okay, for prismatic jump. Now, we didn't have to do it like that here. In the other case, this case, however, it's wise to break it down into 2 rules, because it's very easy to write this thing, and it's very easy to write this thing separately and work it out. So I go here. Actually, I don't need these two. I can either delete it, already deactivate it, or let's say that I don't need this. I'm going to deactivate it because we're going to write rule 2 and rule 3. Rule 2 for the propeller and rule 3 for the block. So let's start with rule. Let's go to for the propeller. So we go to knowledgeware, knowledge advisor. Click on this. I mean, just so that I don't forget, I can change this thing and write it as this is for the prop. Okay, let's do it. So if you look at this figure here, the figure on the right side in the bottom, you use that information. If time is less than, I think it is 2 seconds. 2 seconds. The angle equal to, well, if you look at that, it's 180 degrees in 2 seconds. 180 degrees in 2 seconds divided by 2 seconds, or I can write 90 in 1 second. Okay, so times time, and that's it, right? I don't have a second line which belong to the block. This is why I don't have braces. I don't need braces. You can use braces if you want, but it's not necessary. Else if time less than 6 seconds, then angle equal to 180 degrees. And the last leg of the trip, else angle equal to 180 degrees. Do not forget to add that. Plus, what's the speed there? It is going to go 180 degrees in 4 seconds. So 180 degrees in 4 seconds times parentheses, here's the time, minus the breakpoint, which was 6 seconds. Okay, assuming that there are no syntax error, I'm going to close this, no problem, and do another one. And this one is going to be for the block, right? For the block. Okay. So the breakpoints are different. If time is less than, that is 5 seconds. 5 seconds. The length is equal to 10 inches in 2 seconds times time. Else, if time is less than, the breakpoint is 8 seconds, length equal to, don't forget to do 10 inches. Oh, actually it is equal to 10 inches, right? Right, it stays at 10 inches. Else, the last leg, else, the last leg, length equal to, now look at that, it's going to go 10 inches in 2 seconds. It's the same profile that I had for the previous case. Oops, should be 10 inches in 2 seconds times, oh, do not forget to add in front of this 10 inches plus this. I don't do that. Okay, time, the breakpoint was minus 8, yes, right, 8 seconds. And then in the front of this, in the front of this, I have to write 10 inches plus, but on purpose I'm not going to do that because I want to show you what happens when you plot stuff. You notice that there is a problem and you have to go fix it. So assuming there are no syntax error here, we close it. So we have rule 2 for the prop, rule 3 for the block, and then we go to the DMU kinematics. 10-second, we already have the sensors here. I don't have to do that. So we go over a 10-second interval, and let me close this so that you can see this better. So we play it. You will see something wrong happen when we graph. In fact, you can see, let's check that block, see what happens. Whoa. See? Something wrong is happening here. Okay, now if I activate sensor and graph it. Alright, let's do it again. Okay, so I activate sensor. I suppose I have to rewind this. Okay, let's clear the history. Clear the history. Let's do it again. Okay, and then graph. Something wrong. We'll see. I'll tell you why. And it's going to move again. And we figure out what's wrong. Okay, if you graph it, these jumps means definitely there's some. The propeller is doing what it's supposed to, but not the block itself. Okay, so let's go ahead and debug. So close this, rewind, go to that law that you go to that rule for the block. One problem that I see is right here. This one, it should have been 10 plus 10 inches. Oops, 10 inches plus that. And I hope there are no other error message. There are no other issues here. This may be okay. So save everything. Okay. Simulation with laws. Activate sensor. The first two are activated. Move this out of the way. Let me collapse the tree. So it should go here. Should go somewhere and stops for a while and then move on. Stop. There's still something wrong. We have to find out. Let's graph it and see there's something wrong in our. It's this jump. There is this jump. We have to find out. I have a feeling that, yeah, there is a problem with that, with something that we wrote there. Close, rewind, close it. Let's go to rule number 3 and read it carefully. If time is less than 5 seconds, the speed is 5 inches per second. 10 inches. Ah, right there. This should be 10 inches in 5 seconds, not in 2 seconds. 10 inches in 5 seconds. Yeah. The first leg of the trip. Just look at the plot. First leg of the trip is 10 inches in 5 seconds. It's very easy to make mistakes here, so make sure that you read these carefully, type and be carefully. So let's go ahead. It stops there. And then it moves and stops. And if I graph this, it's exactly the curve that I have here on the right side. This would have been very difficult to run. It would have been very cumbersome to write it in a single rule because you have to break it like that at this point, and then at that point, and then at this point, and here, etc., which is not worth it. Okay? So be prepared for stuff like this on the test. All right? Close, rewind, close, and I want to remind people that when you generate graphs like this, let me do that. So one more time. Oops, stop, rewind, activate sensor, play it. Yeah, stops. Good. So graph it. Now for your test, you have to capture the image here. So for example, in my case, print screen. Where's the print screen button in mine? I can't print screen. I can't find the print screen on my keypad. So let me see for a second. Right there, print screen. So then you can start, for example, a Word document. Paste it. And we're going to check these things. Save this. File, save as. Oops. My test. My midterm graph. And put it in the folder. Put it in the folder that you are going to submit your work. What is that? Right there. My midterm graph. Right there. So if you're going to submit all of these, put that Word document in it so that we can check and see whether you got the right answers, etc. And the other thing, you should be aware of the fact that we're going to ask you to submit these things in specific units. Specific unit. Inches or inches per second or inches per second square. It has to be like that, otherwise we'll deduct marks. Okay, folks? Good luck.